Hey there, fourth grade, this is Mr. C, and this video is about adding and subtracting fractions when they have different denominators. A few days ago I made a video that was comparing fractions, and it talked about this idea of converting fractions using something called the LCD. And the LCD stands for the least common denominator. And so when we add and subtract fractions and they have different denominators, like in this example here, 1/2 plus 1/3, one of the easiest ways to add these together would be to convert the fractions so that they have the same denominator. As soon as we can make them have the same denominator, our work gets a lot easier. And this word convert means to change. We're going to be finding an equal fraction to 1/2 and an equal fraction to 1/3. And I'm going to show you how to do that now. Again, what's important to remember when we add fractions, 1/2 plus 1/3 is not 2/5. We cannot just add the denominators together and the numerators together. So again, if I took 1/2 and I took 1/3, that would not be equal to 2/5. Okay, so we want to convert these fractions so they have the same denominator, and then our work gets a lot easier. And I'm going to show you how to do that right now. So what we want to do, I'm going to go back to our original equation here. What we want to do is find the least common denominator. And in order to find the least common denominator, I'm going to start with the 2 over here. And what I'm going to do is I'm just going to make a list of skip counting numbers by the denominator. So I'm going to skip count by 2. I'm going to find the multiples of 2. So I have 2, 4, 6, 8. You can keep going. Typically you're able to find the LCD in 3 or 4 skip counting numbers. Sometimes it takes a little bit more. And then I'm going to skip count by the other denominator. I'm going to skip count by 3. 3, 6, 9, and 12. And what I'm looking for is the smallest number that they both have in common. And I see in my skip counting numbers that they both have 6 in common. 6 is my least common denominator. And so now what we want to do is find an equivalent fraction. And here's what that looks like. I'm going to change both of these fractions. I'm going to change 1/2 and I'm going to change 1/3 so that they have 6 in the denominator. And I'm going to start with 1/2. Okay, so this is where I'm converting fractions. I'm changing them to an equivalent fraction. So I'm going to start with 1/2 and I want 6 to be in the denominator. I want 6 to be in the denominator because it was my LCD, my least common denominator. When we convert fractions, we're going to be using either multiplication or division. In this case, we're going to be multiplying. So I need to ask myself, 2 times something gives me 6. Here's one of the benefits to skip counting over here. I can see 2 times 1, 2 times 2, 2 times 3. I know that 2 times 3 will give me 6. And whatever I do to the denominator, I need to do the same operation to the numerator. I multiplied by 3 on the bottom. I need to multiply by 3 on the top. I know that 1 times 3 is 3. So this is saying that 1/2 is equivalent to 3/6. I'll quickly just take 3 and cover up 1/2 so you can see that in fact it is an equivalent fraction. 3/6, I know it's way up top. 3/6 is equal to 1/2. So now I'm going to do that same process, but this time with 1/3. So I start with 1/3. I'm going to convert it. I'm going to change the fraction so that it has 6 on the bottom, 6 in the denominator. Again, I'm changing my fractions to whatever the LCD is, the least common denominator. Just like when I was changing 1/2, I'm going to change 1/3. So I need to ask myself, 3 times something gives me 6. I know that 3 times 2 will give me 6. Again, I can use my skip counting numbers. Here was 3 times 1, 3 times 2, 3 times 3, 3 times 4. I'm going to be doing 3 times 2 here. Whatever I do to the denominator, whatever operation I do on the bottom, I need to do on top. And 1 times 2 is 2. So here, I have converted fractions. And if you notice, now my fractions have the same denominator. That was my big star idea. Convert the fractions so they have the same denominator. So now I'm going to substitute. I'm going to go back to my equation here, and I'm going to change these fractions. So I know that 1/2 is equal to 3/6. And I know that 1/3 is equal to 2/6. And if you saw in the previous video, when we are adding fractions and they have the same denominator, the denominator does not change. And then I just treat my numerators like a normal addition equation. 3 plus 2 is 5. So I know I erased my original equation, but if you remember, I was adding 1/2 and 1/3. 1/2 plus 1/3. And we said our final answer, when we add 1/2 and 1/3, we said that it's equal to 5/6. Let's prove that that is in fact a true statement. There's 1, 2, 3. There's 4 and 5. 5/6 is equal to, 3/6 plus 2/6 is 5/6. Or if I use my original equations, 1/2 plus 1/3 is 5/6. Let's take a look at a question that involves subtraction. The process is really, really similar in that we're going to convert our fractions so that they have the same denominator. So for this question, I'm going to be doing 2/5 minus 1/3. I want to convert the fractions so they have the same denominator, and I'm going to use the LCD to help me with that, the least common denominator. I'm going to start with 5, and I'm going to skip count. 5, 10, 15, 20. I'm going to skip count by the other denominator. 3, 6, 9, 12, 15. I can see, I know that green doesn't show up very well, but I can see that they both have 15 in common. 15 is my least common denominator. I want to change both fractions so that they have 15 in the denominator. So let's start with 2/5. I'm going from 5 and I want to go to 15. I know I'm going to be multiplying by 3. Whatever operation I do on the denominator, I need to do that same operation on the numerator. 2 times 3 gives me 6. So 2/5 is equivalent to 6/15. Now I'm going to look at 1/3 and convert that one as well. I'll do it over here. 1/3 I know that 3 times 5 will give me 15. Whatever operation I do on the bottom, I need to do on the top. 1 times 5 is 5. Now my fractions have the same denominator. Now I'm going to substitute them in my original equation. So instead of writing 2/5, I can write 6/15. That's an even trade. 6/15. Okay. 6 is looking a little funky. There we go. 1/3, I can substitute it for 5/15. That's an even trade again. When they have the same denominator, it does not change. And then we treat the numerator like a normal subtraction question. 6 minus 5 is 1. Now my fraction strips aren't going to be able to illustrate this, but if I were to take 2/5 and convert it to 6/15, if I had 6/15 lined up, my fraction strips only go up to 12ths. If I had 6/15 lined up and I could take out 5 of them, I would be left with 1/15. So 2/5 minus 1/3 is 1/15. Thanks for watching.